Imagine right now you need a taxi ride. What are you going to do? Well, I believe for most of us, we would open our phones and call an Uber. For the past few years, companies like Uber, which we call e-hailing platforms, have reshaped the way we travel. While most of us have used one of these e-hailing platforms, not as many people have tried the rideshare option that they offer. We believe ride-sharing is an amazing product that deserves more attention from both the travelers and the platforms.
In this video, I'm going to share our latest research on this topic, named Incentivizing Shared Rides in E-Hailing Systems, Dynamic Discounting. My name is Guipeng Jiao, and this study is completed with my supervisor, Dr. Mohsen Ramazani. This work has been published in the journal Transportation Research Part C, Emerging Technologies. For anyone interested, you are very welcome to take a detailed look.
Now, what is ride sharing? Well, ride sharing is enabled by the real-time matching nature of the platforms, as they know where the passengers are and where they want to go in real time. They're able to pool passengers with similar itineraries together in a single trip. A well-known example will be Uber Pool. The reason why we believe ride sharing is a great service is because of the benefits it provides to the society. For example, it offers a cheaper option for the passengers, which may provide additional utilities. It also requires a smaller fleet to service the same number of passengers, which would reduce congestion and pollution, and may produce higher efficiencies during peak hours when the vehicles are scarce. However, if ride-sharing is such a great service, why isn't it more popular? This is because there are many challenges faced by providing shared rides. First off, passengers will most likely experience longer waiting times, detours, and inconveniences sharing with a stranger, so they need to be compensated with a price discount. But how much to compensate is a difficult question. If the discount is too low, not many passengers will put up with the trouble, then less people would use this service, and it is even harder to pull passengers together. On the other hand, if the discount is too high, the platform will not make much profit, and they will not be incentivized to promote this service. Therefore, the platforms need to think about how to design the ride-sharing mechanism and how to make a profit.
In this study, we propose a dynamic discount pricing strategy for a profit-maximizing platform that is integrated in the matching algorithm. It strategically offers shared trips to selected passengers with individualized price discount. We assume the platform honors the discounts no matter what, even if the passengers do not end up in a shared trip. To approach the problem, we have built a simulation plan based on Manhattan, New York, where we can model the interactions among all the market participants, which include the passengers, vehicles, and the platform. And it allows us to evaluate the effectiveness of the dynamic discount strategy, which can be compared to benchmarks, such as when the platform only offers constant discounts for all passengers in shared trips. From a passenger's perspective, they will join the platform by entering the origin and destination of their trip. Then the passenger will wait to be matched. During this stage, we allow them to cancel the trip and leave the platform if they're not matched within their matching patience. Before their patience run out, passengers can be matched in either a solo trip or a shared trip.
If the passenger is matched by the platform in a solo trip, then they will be notified with the waiting time and the price of the trip. The passenger will then make a choice to accept or decline the solo trip. If accepted, then they will wait for the vehicle pickup. Otherwise, if they're not satisfied with what is offered, the passenger will leave the platform. On the other hand, if the platform offers this passenger a shared trip, then the shared trip information will include the waiting time, detour time, original price, and discount. Again, the passenger will make a choice based on this information. If declined, instead of leaving the platform, the passenger will go back into the system, and the platform will attempt to match them again, but only in a solo trip. As a consequence of allowing passengers to decline the trips offered by the platform, there's an additional type of trip other than solo and shared. That is what we call a forced solo trip. That is when a passenger accepted shared trip, but their counterpart rejected. Then they will end up in a solo trip, but still enjoys the price discount. As for the profit of each trip, we assume the fare structure has the fixed part and the triplets dependent part. For a shared trip, each passenger would pay the discounted price based on the original price they would have paid. And for the driver's salary, we assume they will be paid from their current position till where the last passenger is dropped off. As we have established the market settings, the key problem we're trying to solve is that With a given set of waiting passengers and idle vehicles at any point in time, what should the profit-maximizing matching between the two groups be? Which passengers shall be in shared rides and which shall be in solo rides? Furthermore, what should be the discounts offered to those ride-sharing passengers? Without going into much detail, the strategy we proposed is able to consider countless scenarios, including all the possible combinations of passenger pairs, the probabilities of successful pairing, and the expected profit to be generated. All that are reflected in the equation shown here, and by solving it, the platform can obtain the optimized matching as well as the discount levels for profit maximization. So how did our strategy perform? For the strategy shown by the right line, we can see it outperforms the benchmarks significantly. The dynamic discount pricing strategy allows the platform to increase its pure profit by 10.1%, which can be considered quite substantial for a profit-seeking platform. And at the same time, the strategy reduces the cancellations by over 5%, which is a significant improvement on top of the extra profit generated. Therefore, if we consider cancellation-adjusted profit, the platform outperforms the benchmark by over 25%. In summary, we're able to show that when successfully executed, there's an economic incentive for the platform to promote ride-sharing, which would have a great positive social impact. So next time when you need a taxi, why don't you give it a try?